Yes, good afternoon to you all. I would like to present on the role of geomatics in civil engineering works. My name is Simba Munemero, the principal geomatics engineer from Moja Geomatics South African branch. So there's been an evolution of engineering work service delivery from, if you look date back from predating before 1850, it was highly labor intensive. So when you look in relation to what was happening in survey already had started. Remember, our survey land pass was already started in 1400 BC in Egypt. So we so from 1815 there was a lot of so that's evolution of surveying to geomatics. From predating 1850, geodetic surveys, magnetic, what was mainly used there was magnetic compass and the survey chain. At the same time, in the engineering works, people were in the engineering works, it was highly labor intensive at that time. So much of our surveys was mainly to determination of the Earth's surface. And when you look at what happened after 1850, that was because of industrial revolution and colonization, especially for South Africa. For Africa, there was a lot of, if you check with your history, which you did in Survey 1, you see that there was a lot of control establishment, especially for, if you talk of Africa, in terms of, so in the same manner, what was happening was there are now specialized disciplines. Before there were no disciplines, but now there were disciplines. Then you go to from 1950, going all the way from 1950, automation. Now, because of advent of the computer, development of computer, that's where you'd see that GIS also is a branch of surveying. That's what actually the evolution of from surveying to geomatics started there around in that time when GIS was established as a branch, and as it continued to grow, then in 2020, at the same time in the work in the service delivery for engineering works, due to digital transformation through AI, IoT, 3D, what was also happening in our own, that's why we also started to see the development of robotic total stations, intelligent systems, GPS, IMU, initial measuring units, and of course, in terms of service delivery, building information modeling. So you see, if you look at our project cycle for civil engineering works, you can see that it's a cycle. So from planning, design, construction, commission, utilization, maintenance, decommission, it only depends where are you starting in as a geomatics practitioner. You see that sometimes you'll be starting a project from decommissioning, where we talk of dilapidation surveys or monitoring surveys, where you check where the engineer, when you talk of engineering, civil engineering works, you are considering works that encompass water and sanitation, sewerage, reticulation, structural, transport systems, where you talk of your road networks, and of course others who deal with the rivers and river system. But in much of our, we don't normally do those ones. But at the same time, we are talking of all the engineering, civil engineering aspects. So we come in all these processes. So on the planning, that's where you come up with a building type. Here mainly is the desktop study and the historical data. It comes into play. where you utilize your cadastral data overlay and the desktop survey. You can use your Google Earth, your QGIS. That's where also the GIS aspects are also utilized. It's a pre-feasibility studies are done at that stage of inception planning. That's the stage one, which I will start as stage one, as I said already. And it tells you if the project is a brownfield or a greenfield. A brownfield automatically is coming from a previous or it's a developed area. It's a revamping something which was already there, like from a decommissioning, as you shall see when I will explain. Or a greenfield is, if you are talking of a greenfield, maybe it's a new development, a new town, a new township, a new road, a new reticulation. You're not like a brownfield, maybe it's for let's say for sewer, it was an asbestos. You're now putting a new pipe. So that's where it comes in, where you talk of. So here you talk of the business case. What are the client's expectations? Ourselves, we are basically coming in as a specialist. So it's important to know that we are coming as a specialist. We have our own reports, which we give the engineers. Then they come up with the concept note and scoping report, whereby now it fits into what needs to be the next stage. It tells whether we are going to stage 2, which is the design phase, whereby we're talking of the detailed feasibility studies. Now here, as in our profession, you may now do actual physical boundary location, depending the nature of the nature of the civil engineering works and where it's located. Obviously, when you're talking of an urban setup, it's very critical to boundary location. Then obviously you also have to check the primary control. Where are you getting your primary control, your benchmarks, the fundamental benchmarks, town survey marks, trig beacons close to the project area already, which is identified from the concept note and the scoping report. So here, basically, you obviously now we know how we get our primary control. Either you take from the survey. It depends with which jurisdiction. Here in South Africa, it's easy. You can get it online information and get that online. In Zimbabwe, you have to go to the Surveyor General to get that information, where you can have the locality sketches and also here in other South Africa, other advanced way, it's not just the passive system of primary control. There's also where you talk of your TrigNet here in South Africa, where you're talking of CORES, continuously operating reference system. This is where you actually know which are you supposed to use in that area, which CORES are you going to utilize. Then obviously in that stage, the most critical aspect is topographical surveys. Topographical surveys are basically coming up with you want to come up with digital elevation model or digital terrain model. It can be via terrestrial or aerial, or it's a hybrid. Basically myself, it depends with what the engineers require, but normally the clients, it's very good to have. It's good to have a visual aspect. A visual aspect is important because it tells the client it can actually visual, unlike to just see contour lines and like the old days. So that's why the hybrid is very good. But then in a hybrid, if it's not you just to take a 2D aerial photograph, you can either take it from already from aerial photos from satellite imagery, which is already you just get. They may be free, depends with your resolution which you want. You may actually need to buy them, or you may just if you have a drone, or you can have someone to fly it if that's what the engineer requires. But it's very good because if you produce such, you would see that it makes it easier for the client to actually take up the design, especially from the visual perspective. And even the engineer, they would even understand. Sometimes when you take these topographical surveys, it's always boring to always come in and be told that can you go back and pick up 1 or 2, 3. So, but when an area, you can actually see, you can actually remember if it's a 3D big data that you have collected there, or if it's photogrammetry or you have used LiDAR, you see that if there's something missing, you can easily extract the information. You already have it with you. So I urge you as geomatics practitioners to just help make sure that you have this data. It makes you life easier, so not to go back into the field. So here again, from the topography, remember you don't establish secondary control. You may put working stations when you're putting a topographical, but not the site control, because the design has not yet been approved and you don't know what the engineer is going to design, how he's going to design it. Especially, let's say it's a road or it's a water reticulation, you may put it, you may think it's the left side, right side. If it's a road servitude, already you know from the cadastral, but the road, it's not always on the center. It can be to the closer to one to the left side of the cadastral, to the other side. So you have to wait for the design first to be approved. Then of course you can go on in the field and put your site control. Of course, this is again in this stage. When you talk of in terms of building information modeling, I'll just go to the database. Go to the database. This is whereby building information modeling is basically it touches all in the workflow or engineering works. This is now, I'm not saying every project they utilize it, but it's a good approach because it encompasses our geomatics, because our profession, because we are actually required there as the database manager. So it is interesting that in all the stages, you are in the thick of things, especially those who are well versed in not just GIS, but you also have to be well versed in a bit of programming or software engineering in terms of this. But these things are easy, right? These days you can easily learn. So in the building information, at that time when now the engineer is designing, remember he's now designing on the platform of the BIM, which has been, as I said in the inception, there was a programming which was done. All the drawings, not these 2D drawings that normally are used or which you see when they're printed. Everything is there in the model space. If those who understand a bit of, I think all of you understand computer-aided design. What it means is the BIM now you can actually do virtual simulation by VR, virtual reality simulations of the construction site. From there, you can actually do walkthroughs. As all the project members who are, be it if it's a project whereby there are other, obviously it's not maybe an architect, there are others, there are others who are structural engineers, electrical engineers, mechanical engineers. All of us, we come in there, but basically the one who is in charge of this system, it's what the geomatics practitioner. It's also when this, the good thing about this, when it's the simulation, it actually gives you an impression of how the construction will look like. So it also makes it easier for documentation for tendering. The documents that are produced in this, when you are utilizing BIM, you ensure that there are no errors. I think you have seen that most of if you are using the old system, most of the drawings for tender, they are not normally, they are different from the construction. But when you are utilizing this one, it is a workflow of once and for all. You know that, of course, there will be errors and there will maybe changes from the client, maybe they change, but your documentation, you know that is spot on, which is good for, in terms also from the quantity surveying aspect. It means that the takeoffs, when you talk of your BOQ, you don't miss anything when you utilize. I'm just giving out how we have BIM in terms of us as geomatics, as the data managers, is critical for, because now the information that they extract, these are not, they are of course estimations, but they are at least within, if you are talking of your GCC, it's within 15% of the allowable. If it's going to there be inflation or whatever, at least they will not miss anything. Because I've seen several projects whereby you can miss one thing, and at the end of the day, people end up fighting on the project because the budget, now you have exhausted the budget, maybe you may not be able, the scope has to be reduced to finish the project. That means some other things have to be removed. But with this aspect of design, it makes sure that in design, everything is captured. So that's the design process. The design process, you see that, I'll just how it will look like, but us will see that it's information gathering. That's where we come in. And also, obviously, when the workflow, as I said, the BIM itself, if you are utilizing BIM, we come in as making sure that we manage the data. Of a civil engineering aspect, obviously, it's not our data, but we know where to place it. Remember, when on topology in GIS, you know what layer this is and whatnot. So this is critical for decision making, so that they can act. That means that from the design process now, the design process, we moved into stage 3, which is stage 3 is the construction or execution. Construction execution, obviously, it comes after tender process has been done. Design process. Yes. So here, as Geomatics, again, we come in to set out the structures, to set out the civil engineering works, whatever it is, we do the setting out. Then, in terms of when we are, of course, this is done by the contractor who has won the tender. Then, obviously, checking for quality control and assurance, from the implementation, the consultant, there will be the consulting surveyor or geomatic practitioner who will be able to check. Now, because if you are utilizing BIM, this is easy. Everything, when it is done, that information from the contractor is given into fed into the building information modeling workflow, so that you check whether to check the tolerances, what the design and what has been set out. Is it in according to the tolerances, according to the standards that the jurisdiction, or according to how the engineer or the architect has set aside the tolerances. Then in terms of other things that we also do, our construction survey. Construction surveys, there are various in terms of the main one, obviously, the taking levels. That one, leveling, of course, there are also vertical alignment, to check the alignment, profiling, all those. Then monitoring, this is critical, depend with the nature of the project. For skyscrapers, though high-rise buildings and bridges, it's critical for monitoring surveys, deformation monitoring per se, where the engineers, they ensure that they have certain bolts that are put on that structure as it is being constructed. You yourself, you have to check every day to check the position. As they changed, is there settlement? Is there a shift? What are the mean shift? Normally, everything settles, especially if you talk of concrete. Some may be surprised what is happening, but you need to know that there are tolerance also for all things as it sets. But everything, it is critical for you to know that it is important for you to do monitoring surveys for certain projects. So in terms of BIM, it is critical for in the implementation, in the construction of project management. BIM building information modeling is a useful tool for construction project management. So you see that you can easily mitigate, you can easily your risk, whatever it actually gives you, because it brings all professions, or is a multidisciplinary. It brings you all together, and the documentation is in one. I think you have seen that with your projects that you have done. You may miss one drawing, and it can get all things out of perspective. Let's say maybe it's your steel, for reinforcement steel. Maybe they are not the same as with the concrete drawing, the section drawing. You may not be easy to see it there, but with building information modeling, everything is in one. So that's I'm just coming in where we need to up our game on the last stage, closed out. This is where we do our, this is where the tests are done. Tests are done, commissioning is also done. Here, you see that there are certain projects where we would, in testing, they will test your levels. Are they correct? Is it in position? Is it alignment? For say, your vertical alignment for high rise, is it within tolerance? You may find that sometimes there may be a slight a shift in certain columns, as per se, from what was been designed, and there may be certain things that need to be done so as to rectify. For instance, if it's a sewerage reticulation, the tests actually come in there. Remember, I said we are also quality in terms of quality control and assurance. The commissioning is basically to hand over the on completion, and what is required there are, of course, as built surveys. Then obviously whatever that is done is finalized in the is fed into the BIM to finalize. Of course, the documentation that comes out, the blueprints for the works that have been developed. So that's where the close out, you find that there's a close out report, whereby also in terms of us as Geomatics, we also come in there to come up with from our as built surveys. They come in, they are very critical in terms of the close out report so as to get the retention money that the client has held, so that they know that you'll be able to finish. In that time also, you may also be in the defects liability. Here, I'm just combining to utilize, maintain, and decommission. Remember, I said on the stages above there, the stages that I have shown you, that let me go back a bit so that you see where we are on the project cycle. Utilization, maintenance, and decommissioning. So utilization now, in the defects liability period, you're still, as a contractor is still, even the implementing agent, the consultant, they're still, it's not yet been finalized. The final whatever completion of certificate has not yet been handed over, but it is critical there that Geomatics still plays a part in terms of the data management. Of course, if there's anything that comes in which is not correct, obviously the monitoring surveys come into play, or you may need to be brought in for a forensic survey if they feel that there's something that is amiss with of course, they may have handed it over, but because it's not working well. So this may also lead, again, or other stages, in terms now, if it's in the client's hands, the local planning authority, or let's say local council, government, whatever, whoever the client is, they also have to maintain, maybe they've got a unit in them. Maintenance, it comes into play in terms of monitoring surveys, depending with the structure. For instance, the pump stations and, as I say, high-rise bridges, these things, they need always to have deformation monitoring done, or demos. So in terms of this, also remember everything has a lifespan. I think you can know with our road in Zimbabwe, Bait Bridge, Harare, is it Chirindu Road? It is design life. Everything has a design life. Everything that is built, man-made, has a design life. Whether it's for roads, those, it depends on the road. Distributor roads, the small ones which we see in maybe 5 to 10 years, those streets that we see in arterials in our neighborhoods. But for highways, it may be as much as 25 years. So in terms of decommissioning, this is where we'll also come in, in terms of to decommission. I think you know what you have Harare Bait Bridge, surveys had to be done. Surveys had to be done, and we came in to check, is it feasible? Like, remember what the decommissioning of, that was an upgrade, the Bulawayo Road, it was a resurfacing, instead of just a it was just a resurfacing without much layer works being done to be redone. But unlike our Bait Bridge, it was seriously worn out with a lot of settlement. The base was really destroyed. So Of course, you may do also reclamation. That's where also, depending with the nature, if it's a pump station, for instance, you may need to just change maybe the digester or the mechanical components. You may need to do what we call a retrofit, or where you come in, reverse engineering comes in, just do maybe your 3D scanning technology, or even a total station, just pick a certain point, but making sure that your accuracy is as high as possible, depending on, but obviously, because if it's a retrofit, it means you want to remove what is there, but it wants to put back exactly as that, but that thing may have been built maybe 20, 50 years ago. So that it has to be measured. It has to be as it is. So that when you take it to the manufacturer, or is taken to the manufacturer, it is going to be developed as it is, where there are bolts, where all the things are coding. So obviously 3D scanning becomes the choice for us as geomatics in our profession. Again, building information modeling remains in terms of managing, and I'm just specifically on, but obviously geomatics and data management, all of it encompasses all. So, but in terms of managing and operating whatever has been, that is civil engineering works, building information modeling still plays a role. So in the project cycle, you see the building information workflow. You see that you see the conceptual design, programming. All these it's on that in inception. Detailed design is on that design itself. Detailed design analysis and documentation. Documentation again, that's where it goes for tender. Then fabrication, construction, 4D. That's where you're actually doing the construction now. Fabrication, maybe your suppliers to fabricate. Maybe there are some certain things like say beams that need to be roofs that need to be fabricated a certain way. Mechanical components need to be, so it has to be done prior to already the tender is out. The contractor is one. Fabrication obviously depends with the nature of is it whereby you nominate suppliers as the implementing agent, or the contractor has to do it on their own. All those things, they come into hand there. But our main is to make sure that we manage this workflow. You understand? So this is if I'm talking of in the civil engineering works, building information modeling. We are now talking of, we are in 2022. So obviously, all the information that all other professions come, they feed in, whether they are suppliers, you are the one who is making sure that it is within this workflow. It is within this workflow. Whether you are now constructing, whether it's now a renovation and upgrade, remember, renovation is part of decommissioning. You are changing something. So at the end of the day, this is what I had for you. It's just a presentation. Again, I put it yesterday, but I just felt that maybe there are others who wanted to hear what this was all about. So are there any questions? We just have 10 minutes. Any questions? Mr. Matar? I'll take it that, okay, this is the end of the presentation. I will share it. It will be shared on the youth forum. So have a nice weekend. Thank you. Are we? Belinda, how are you? How are you? How are you? Titus. The presentation is over. Anyone with a question? Hello. Yes, Mr. Titus. Okay, if anyone has a question, you can ask in, come inbox. So I'm going to share the recording sometime later. It will be given out by those tech-savvy guys who will give you that recording. So have a nice weekend. So this is the end of the presentation. Enjoy.